6.5, we're starting to graph inequalities and looking at system of inequalities. So to graph inequalities, we treat it just like graphing a regular old line. But it says, here's the steps. To graph inequality, follow these steps. Solve the inequality for y, unless it's a vertical line, because then it would already be x equals. Graph the boundary line. So let's just talk about graphing. If I were to graph this line, y equals negative 3x minus 2, I would start at negative 2, and then I would go down 1, 2, 3 over 1, right 1, right? Or up 1, 2, 3, backwards 1, and that would be my line. But since it's an inequality, there's some specific rules. So if it's greater than or less than, we use a broken line to graph it. If it's greater than or equal to or less than or equal to, we use a solid line. Well, in this case, this tells me it's equal to, so that's a solid line. So, oops, sorry. I am going to graph it using a solid line. Here's my graph. I still use arrows, fill out my thing. And then it says, pick a test point to decide which half of the plane should be shaded. So, if I pick a test point, so I'm going to pick this point 0, 0. So if I pick 0, 0, I would have 0 less than or equal to negative 3 times 0 minus 2. Is 0 less than or equal to negative 3 times 0 is 0, negative 2. 0 is not less than or equal to negative 2, so 0, 0, that point can't be in my shading. So I am going to shade this. So any point that's in the shaded region will work for this graph. Another way you can think of it is if you look at it when you have y, solve for y, I'm just trying to erase that little test point. So if I look at this, if it's y is less than, I shade under the graph. So this is y is less than, this is under. So if you think about it, if this is my roof of my house or part of my roof, it would be under the roof. So that's less than or equal is under. If it's greater than or equal, I shade above the line. So this would be the graph of that inequality. So let's just do some more. So it says solve for y, right? So this one, y is less than 4. Well, we know our y equals 4. Remember, that's the one that's a line. You go up 4 on the axis, the y-axis right here. I know that point's there. And y is 4 all the way along this horizontal line. And this just says y is less than 4. So since it's not less than or equal, I can't make a solid line. I have to make a dashed line. So here's my dashed line with my arrows. And everything less than y equals 4 is all of this. So all of these things work. All right, the next one says x is greater than or equal to 1. Remember, x is equal to 1 right here. And everywhere along this line, this vertical line, that's not a very good vertical line. And since it has the equal to, greater than or equal to, it's a solid line. And I shade greater than is going to be on this side. All of these numbers are greater than 1, so they would all be shaded. Let's see. This one, y. Some of you like to rewrite it. If I rewrite this, if I put the y over here, here I have the open side facing the y, so I still have to have the 2 points facing the y. And this is plus nothing, right? So I start at 0, and then I go up 3, 1, 2, 3, right 1. So it's a rise of 1, 2, 3, a run of 1, down 1, 2, 3, or backwards 1. So this is my line, and again, I look to see it's greater than or equal. There's this line here, so I know it's a solid line. And again, if I think of this as the roof of my house, if it's greater than, I want Well, either we can pick a test point. So a test point, I can't pick 0, 0 in this case because 0, 0 is on my line. So I'm going to pick, let's pick 0, -2. So I'm going to pick -2, 0. So -2, 0. 0 greater than or equal to 3 times -2 plus nothing if I put that on there. Is 0 greater than or equal to -6? It is. So that means that this point that I picked has to be shaded. So it's all of this. Or I could have just looked and it says y is greater than or equal to my line, so I know I shade above the line. Again, if it's the roof of my house, it goes above the roof, so that would be where it would be shaded. All right, graph the following. Hey, this one always kind of throws kids. This still is just y. I'm going to rearrange it because we're going to have y on this side. This time y has the pointy part facing it. Again, this is just a regular equation. There is no number to start with, so I start at 0. And then my slope is, remember, this could be thought of as a -1. So if I go down 1 and right 1, down right 1, down 1, right 1, or up 1, left 1, and again, it should look like it's going downhill, right, because it's a negative slope. Now it looks like a positive. So this was a slope of -1x. And it says y is less than that. So I have a dotted line because there's no or equal to. So dashed line, arrows on the end, and less than is everything under that line. So that would be that. This one we have to rearrange because we need, in order to graph it, we need it to say y equals. So how do I rearrange that? I am going to remind you that when we have inequalities, if you have a negative, you divide or multiply by a negative, you have to flip the switch. So I'm going to make my y positive so I don't have to worry about that. I'm going to put my y on this side and make it positive. Then I have x is greater than or equal to 1 plus y. I still have to get y by itself, so I'm going to subtract 1. I know I always told you to leave y alone, but I don't want my y to be negative. So here I have x minus 1 is greater than or equal to y, or rewritten, y is less than or equal to x minus 1. So if I graph that, again, I start at -1, up 1 over 1, or down back. And it is a solid line because there's the or equals to. And it says y is less than, so it's shaded. And these shouldn't be straight lines for you guys. I can't shade with my pencil. You should turn your pencil on the side and shade that region in because it's everything in that region, not just the line. So it's all of this. I just can't shade very well with this smartboard. This one, again, we have to get y by itself. This time I'm going to deal with the y being negative just to show the difference. So I'd have -3y is less than or equal to -2x plus 6. I have to get y by itself. I'm dividing by a negative number. Remember, if you divide or multiply by a negative number, you have to flip the switch. So flip it to face the other way. I have -2 divided by -3, which is just positive 2/3 x. And 6 divided by -3 is -2, so -2. So y is greater than or equal to 2/3 x minus 2. Again, start at -2. And then my slope is rise of 1, 2, and a run of 1, 2, 3. Rise of 1, 2, run of 1, 2, 3. And it's y is greater than or equal to, solid line, because it has greater than. And I shade above my line, so it's all of this part. That's really all there is to this. The rest is just practice, so I'm not going to worry about those. So let's look at this. Is 3, 6 a solution? We had that test point in the beginning where we actually tested to see if something is a solution by just picking a random spot on the graph. It's kind of the same thing. I'm just going to plug this in. This is my x and my y. So if I put 6 in for y, is that less than or equal to 2/3 of 3 plus 4? Is 6 less than or equal to, these two cancel out, so I'd get 2 plus 4. Is 6 less than or equal to 6? Now, a lot of times kids say no because it's not less than, but it has to be either less than or equal. It can be either one. Since it is equal to 6, this is a solution. So is it a solution? Yep, it surely is. Is 1, 2, and 3, negative 7 a solution of y is greater than x minus 3? Again, you just have to plug them in one at a time. This is your x, this is your y. So 2 greater than 1 minus 3. Is 2 greater than negative 2? It is, so that one works. Now let's try the other one. Negative 7 greater than negative 3 minus 3. Is negative 7 greater than negative 6? If you think of it on a number line, because this kind of throws kids, because 7 is a bigger number than 6, but here's 0. There's negative 6. Negative 7 is further in the negative area. So that numbers get smaller when we go there. So negative 7 is not larger than negative 6. So this is a solution. And this is not a solution. So yes and no, actually. Oh, shoot. Well, we could have graphed it and checked, but we just did it without graphing by just plugging them in, which is definitely a viable option. That is it for this lesson.